In this video, we will look at multidimensional arrays. In particular, let us look at two-dimensional arrays, because that will give you an idea of how multidimensional arrays work. Initially, let us look at them as arrays, and in a subsequent video, we will look at the connection between multidimensional arrays and pointers. Okay. So, multidimensional arrays can be defined in the similar to the following. You can say double mat 5 6 or int mat 5 6 or float mat 5 6. This is similar to the mathematical notation of multidimensional arrays or matrices. So, let us look at the first example. We have that the definition states that mat is a 5 by 6 array of double entries. So, this means that mat has 5 rows, each row contains 6 entries, and all the entries are of type double. Now, double is what is known as double precision floating point numbers, and if you are doing a lot of floating point computations, then instead of float you could use double, because you might need a lot of precision in your computation. So, the matrix 2D array might look like this. This looks like a mathematical matrix of size 5 by 6. So, it has 5 rows, rows 0 through row 4, and each row has 6 columns, column 0 through column 5. Now, the ijth member of matrix is accessed as mat ij. This is slightly different from the mathematical notation. In mathematical notation, you will write matrix and then a square bracket, and then you will write I comma j followed by close bracket. So, this is different. In C, you would write the indices separately in their own square brackets. Now, the row and the column numbering begin at 0. This is similar to one dimensional arrays. We saw that one dimensional arrays start with index 0. Let us look at a function which prints the input matrix. Okay. So, I have a function, it returns void. So, it does not return anything, it just performs an action, which is to print a matrix. Now, the function is called print matrix. It takes a double matrix, a mat of size 5 by 6. 5 rows, 6 columns each. I first declare I and j. I is supposed to iterate over the rows, and j is supposed to iterate over the columns. Now, how do you iterate over the whole matrix? Well, first you would take each row I. So, you need an outer loop for that based on the variable I. I will go from 0 to 4. Okay. So, the for loop goes from 0 until you hit 5. Now, for each row, what do we have to do? We have to take the elements in the column. Now, the columns are numbered 0 through 5. So, for each ith row, we have to take column 0, column 1, column 2, column 3, column 4 and column 5. So, all these entries, and then you have to print that entry. Now, we have just mentioned that the ijth element in the matrix is accessed as mat ij, I in square bracket and j in square bracket. Therefore, you will say printf %f followed by a space mat ij. So, this will take the entry in the ith row, jth column. Okay. One more thing that is worth noting is that even though you had a double matrix, you still print it as %f, as though you were printing a float, and the language will take care of printing the double precision. So, here is the loop to print the columns of a row. Once you are finished with a row, you would print a new line, because then you can start at the beginning of the next line for the next row. So, here is the loop. So, what the loop does is prints the ith row, row starting from 0 and ending in 4, and for each row print each of the 6 columns 0 through 5. Now, at the end of each row you would print a new line. So, here is the code to print a matrix. The lesson here is how to access the ijth element. You would access it as matrix square bracket I square bracket j. Now, the dual operation of printing is of course reading in the input from the user. We have done it using scanf. So, let us try to use scanf to read in elements which are input by the user. Now, one of the things with scanf is that the argument to which variable we have to read it in, we usually give and x. If we have to read it into a particular variable x, then we will say scanf whatever format it is and then say and x, right, which says the address of x. Similarly, I could guess that in order to read to the ijth element of a matrix, I would need and mat ij, and that is actually correct. You do not need a parenthesis here to write. So, you do not need to write and of mat ij with mat ij in square bracket, because the address operator has lower precedence than the array indexing operator. So, when you see an expression like this, the parenthesis will be in such a way that mat ij is evaluated first and then the address is taken, because it is a lower precedence operator. So, this is similar to a one dimensional array that you have already seen. You would have read it using and of a I. So, we have the two dimensional analog of that. So, let us look at the code, and the code looks exactly as the print routine, except that we are now scanning a number. So, you have an outer loop which will go through all the rows, and then an inner loop which will go through the columns of the ith row. And how do you scan? You say scanf %f and mat ij. So, remember, if it was just a double variable instead of an array, you would have just said and of the variable name. Similarly, we have and of mat ij. Again, note that even though we have a double array, you read it in exactly as though it were a float array using %f format. So, read in the ith row, and the ith row goes from 0 through 4, and for each row read the jth column. Column goes from 0 to 5. Okay. Now, the way the scanf works, the scanf with %f option will skip over the white space, and it will skip over any white space. So, in effect what it means is that if I had to enter a matrix of size 5 by 6, I can enter it in multiple ways. I can enter it in the most natural way, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. So, 5 rows. Each row is entered in a line, and each line has 6 entries. Okay. So, let us call this maybe 10 and 11. So, each row has 6 entries and there are 5 rows. This is the most natural way to enter it, but as far as scanf is concerned, any white space will be skipped. So, instead I could just enter one number in one line. Okay. So, I could enter it line one number per line, and it would be read exactly in the same manner. Okay, that is the property of scanf. So, it really does not matter whether the entire input is given in 5 rows of 6 doubles or just 30 doubles, each number in a single row by itself. So, that is both of them are fine. We have seen how to print an array, we have seen how to read elements into an array. Now, let us see how to initialize a multidimensional array. So, we want to initialize let us say a 4 by 3 array in the following way. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0, 1, 2. Let us say this is the array that I want to enter. Now, we have seen initialization of one dimensional arrays. If I had let us say int b 3, how did we initialize it? We could initialize it as 0, 1, 2. Okay. So, the summary of this is that it is a list of numbers separated by commas, and the list is enclosed in curly braces. Okay. This is the case for a one dimensional array. So, it is natural to generalize the notation in the following way. If I have to initialize a 4 by 3 array, I can just say curly brace, and so here is a list of elements, and each element is basically a row, right. So, what is a number here will be a row. So, it will be a list of rows, and each row being somewhat like an array, each row will be given by a list. So, the list the array initialization on the right hand side is exactly the array that is shown here. So, it will come out to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. So, the notation is consistent, and it is a generalization of the one dimensional array notation. So, there are some initialization rules similar to what we have seen for one dimensional arrays. Values are given row wise. Okay. The first row, the row number 0 is the first entry. Number of columns needs to be specified. We need to know how many columns there are. Now, value of each row is enclosed in double braces, enclosed in braces, curly braces, and the number of values in a row may be less than the total number of columns. This is allowed. This was similar to how we saw that even though you had declared the size of an array, you could give less, one dimensional array, you could give less than that number of values as the initial values. The remaining values will just be 0. Same case occurs in the multidimensional array. So, let us watch an example. If I have an array A3, number of rows unspecified, number of columns 3, but each row, let us say I have 3 rows, each row does not have exactly 3 elements. The row 0 has just 1 element, row 1 has only 2 elements, and so on. It will be initialized as 1, 0, 0, because in row 0 I have given only 1 element. So, that will be the first, and the remaining will be 0. 2, 3, so I am short of 1 element, that will be 0. 3, 4, 5, I have 3 columns and I have given 3 values. So, it will be initialized as 3, 4, 5. So, the list, the initialization on the left hand side results in the matrix on the right hand side. Here is how initialization works. Now, let us look at access mechanism in somewhat greater detail. So, let us ask the following question. Instead of matrix 5 by 6, okay, I have written a function to read a matrix of size 5 by 6. Can I give a 6 by 5 matrix? So, this is a matrix of 5 rows, 6 columns each. Instead, can I give a matrix of 6 rows, 5 columns each? The total number of elements is still 30. Would it be the same, or would it be even a matrix of 10 by 3, 10 rows, 3 columns each? All of these have 30 elements. Now, as far as C is concerned, are all these the same? Okay. The answer is that no, it is not correct, and neither it should be, but we will say that the answer depends on the way the array elements are accessed. Okay. So, we will see this in greater detail. So, in order to motivate that, let us introduce the problem of passing an array to a function, and let us look at the issue in greater detail. Suppose I want to take a 2-dimensional array of type double 5 by 6 and print the sum of entries in each row. So, this is similar to a matrix program that we have seen much before. Given a 2D matrix, for each row you have to find the sum of elements in each row and just print it out. Okay. So, in mathematics this is often called marginals. So, let us just compute the marginals. We have a function void marginals, it takes a matrix 5 by 6, it has int I j, I is over the rows, j is over the columns, and I also have a row sum variable to keep track of the sum of a row. So, what do? I have an outer loop which goes through all the rows. for each row I initialize the sum to 0. Now, for each row I have to sum all the elements in the ith row. So, I have to sum all the elements in the columns j through 6, j 0 through 5 of matrix I j. So, I will go through the elements and add them to the row sum. Once I am done with the last column of row I have the row sum for row I, and I will print that. So, this printf is happening in the loop for row I. Okay. Now, let us look at a slight modification. We say that instead of printing 5 rows, I currently have only 3 rows of entries available. So, can you print me the row sum of the first 3 rows instead of all the 5 rows? Now, this is very simple. Let us just modify the function a little bit. It takes an additional parameter saying how many of the initial rows do you want me to sum. So, that is an additional parameter. Let us call it n rows. So, here are the number of rows for which I have to take the sum, and that function is a very small modification of the sum that we have already seen, the function that we have already seen. The difference is that we now take n rows, which is like how many rows do we have to add, and then for I equal to 0, earlier I would go from I equal to 0 to 5 because the matrix had 5 rows, but now I will just say I will go up to n rows, and the logic is the same as before, nothing else changes. So, here is the strange thing, C completely ignores the number of columns. For as far as the C language is concerned, if you have a 2D array, the number of columns is crucial, it has to be specified, but the number of rows is not really important. So, C completely ignores the 5 part, the number of rows. Now, this means that we could pass less than 5 rows into the same function, since we are not checking, for example, that n rows is less than or equal to 5. So, let us see an example. Here is the completely surprising example that this code is the same as before. The only difference is highlighted in red, that I have now omitted what is the number of rows. Please relate this back to the codes that we used to write for arrays. Earlier I said that for an array you do not need to specify the number of elements in the array. When you write a function taking an array as parameter, I could just say int arr and then empty pair of square brackets with no size in between, right. So, we have a similar phenomenon for 2D arrays, except you are not allowed to omit both rows and columns. You have to specify the number of columns, but you have the flexibility that you are allowed to omit the number of rows. So, the number of rows is not important, you could omit it and just give an empty pair of brackets, and the code will work as before. So, this means that the above program actually works for any k cross 6 matrix, where k could be the number of rows, and this is because C does not care about the number of rows, only about the number of columns. And why is this asymmetry? Why is it that it cares about one element, but not the other, the number of rows, but not the number of columns? We will see this using the 2-dimensional array addressing. Let us say that I have written a code for computing marginals, and it takes these parameters double, mat, empty pair. So, the number of rows is unspecified, the number of columns is 6, and then it takes an additional parameter n rows, which says how many rows should I add, right. And then I am calling this function. Suppose I have defined the function elsewhere, and I am calling this function from main. So, I declare a matrix 9 by 6, and then I will call marginals on just the first 8 rows, not the 9th row. So, I pass a subset of the rows. This is fine, because I have declared as a matrix of size 9 by 8, but I am passing only 8 rows to marginals, and that is fine. I can pass a subset of the rows. What is definitely not fine is, suppose you declare a matrix of size 9 by 6 and say that I want to add, I want you to find the marginals of the first 10 rows, then this is unsafe, because yeah, it is true that the marginals function does not really care about the number of rows. So, it will work for any k cross 6 matrix, but you cannot hope to pass arbitrary junk values to that matrix, right. For example, you have just declared a 9 by 6 matrix. Okay. Now, the 10th row of the matrix is basically invalid. Okay. So, if you pass it, you could expect your code to receive a segmentation violation when you run the code. So, when it processes the 10th row, what it has basically crossed the limits of the array. So, the code may have a segmentation violation. So, note the difference between saying that it could marginals could work with arbitrary k cross 6 matrices. It is still true that if you pass junk values to the matrix, your code will crash. If your code is a valid matrix, then you can pass an arbitrary number of rows inside the matrix. Okay. So, the summary is that, as with one dimensional arrays, you should allocate your array and stay within the limits allocated. Within those limits, the number of rows does not matter, but it does not mean that you can overshoot the limit and hope that your code will work. It may not, and it can crash.